This is an air-powered gyroscope. So instead of needing a string to start this, as we did with the old-fashioned top, we're going to use an air-powered gyroscope which has a turbine on the inside. An air turbine, just like a jet engine. So as I blow into the side, you'll hear a sound. That is the air turbine spinning on the inside of this air-powered gyroscope, the whirlwind. And again, having gyroscopic stability, it remains horizontal, tends to resist tilting over. Because these have metal bearings, they hold up well, so we can keep using this over and over and over again. And it teaches several other physics, but if I had you here in front of me, I'd play a little trick on you so you could see how these really work. Some fun stuff. Now let's slow this down a little bit. Again, I may have to work at this because these have very good bearings. When it slows down, it will start to wobble like any other top or gyroscope. Again, gyroscopic precession. We'll speed up the wobbling if we can. There we go. Gyroscopic precession, which is bing, bing, crash, which is our enemy with a lot of toys. Gyroscopic precession is. But it's our buddy with some other toys. So we'll demonstrate a toy now in which that gyroscopic precession is our buddy. This is a toy called the gyro ring. This toy works by gyroscopic precession. To operate it, I need to hold it from above firmly like this and put the heel of my hand on the tops. If you run your hand across this, you get the tops to wobble. That wobbling is gyroscopic precession. Just like a big hula hoop going around your waist, like this green one on top, that would be one hula hoop, and then the pink or purple one would be a second hula hoop, and then the yellow one there would be a third hula hoop, and the blue and the orange would be the fourth and fifth hula hoops. As long as we keep making our waist go taller and taller and taller up into the air, as long as we keep making our waist go taller and taller up into the air, the hula hoop keeps falling down our waist by gyroscopic precession. And if you want to get fancy, you can add some other tricks into it to make it more challenging. And that last trick, the giant flip. The only way we can do this is by accelerating. And accelerating is when you change how fast you're moving. That's accelerating. If we increase it, the speed that we're moving, we think of that as positive acceleration. If we decrease, that's a negative acceleration or deceleration. Since it's a welded stainless steel ring, we don't have to worry about if we drop it. So, let's get on to something else weird. How about, let's use this. This is the tornado tube. The tornado tube demonstrates a vortex like a whirlpool or a whirlwind. In the center here, the vortex is being accentuated by colored lamp oil. If you're on a black and white television set, you might not see that all that well, so I'll flip it over and use the clear side. The colored lamp oil is lighter weight than the heavier water. The heavier water falls to the outside, and the lighter weight lamp oil remains in the middle with the air. Now you'll notice that I'm rotating this counterclockwise. That's actually the direction that tornadoes in the atmosphere, which operate by the same physics. With a tornado, an atmospheric tornado, it's formed by a heavy, cold upper air mass, which is falling through a warmer, lighter air mass. As it does so, as it falls, it goes faster and faster, and due to the rotation of the Earth, there's an effect called the Coriolis effect that causes this to rotate. The greater the air mass falling through this warmer, lighter, hot air mass, the faster this rotation will be. And so during tornado season and hurricane season, we have these dangerous vortexes. A galaxy is another example of a vortex which rotates more slowly around the outside and faster on the inside, which is actually an effect called conservation of angular momentum.